Okay. Now let's see question 5a, distinguish between parametric and non-parametric models and supervised versus unsupervised learning with examples. So I've shown a table with clear example from both crime data sets and student performance prediction. Let me walk through each row in detail. So parametric plus supervised. Parametric models assume a fixed mathematical form. They learn a limited set of parameters, for example, coefficients and regression. They work well when relationships in data are simple and well defined. Crime example. On my slide, I have shown logistic regression being used to predict the probability of BNS 80 dowry death. This is supervised learning because we already know the target label, which section applies. So, in student example, here we use linear regression to predict exact and end semester marks. Again, this is a parametric because the model structure is fixed, and supervised because we have label data. Now, non-parametric plus supervised models. These are models that do not assume a fixed form. They can grow in complexity depending on data. They generally give higher accuracy because they adapt to patterns more flexibly. In crime example, I have shown random forest, which is one of the best performing models for crime section prediction because it captures complex nonlinear patterns in FII data. In student example on the right hand side of the slide, the example is shown in XGBoost, which is often gives a 94% accurate grade prediction. It is supervised because it learns from labeled marks. Now, unsupervised models does not use labeled data. The goal is to discover hidden patterns or structures. Crime examples, I have shown K-means clustering for FIR into 5 crime types. Here we do not label the data beforehand. The algorithm discovers clusters like dowry-related, land dispute, injury-based, domestic harassment, and so on. In student examples, similarly, K-means can cluster students into groups such as consistent performers, struggling students, last-minute learners. This helps identify intervention strategies without needing labeled outcomes. So, overall, the parametric models are simple based on fixed formulas. Non-parametric models are flexible and more powerful. Supervised learning uses labeled outcomes, and unsupervised learning finds natural patterns in raw data. Moving on to the next question. Define accuracy, prediction, recall, F1-Score, and illustrate computation using confusion matrix. Now, this question asks for the definitions of accuracy, precision, recall, and F1-Score with their computation in a confusion matrix. On the slide, I've shown both the theory and numerical confusion matrix with example. So let's go through it step by step. TP represents the true positive, model correctly predicts positive, it means. False positive, model predicts positive, but it is actually negative. False negative, model predicts negative, but the case is actually positive. True negative, model correctly predicts a negative. These 4 values form the basis of almost every classification metric. Now, using the numerical example, here the confusion matrix shows true positive as 80, false negative 20, false positive as 10, true negative as 90. So, first we calculate the accuracy here, the formula which tells us out of all the prediction how many we were correct. Formula for it is true positive plus 2 negative divided by false negative plus 2 negative plus 2 positive plus false positive. And it turns out to be 0.85, which is 85%. This means the model is correct 85% of the time. So now next is precision. Precision answers the question when the model predicts positive, how many were truly positive. Formula for this is true positive divided by true positive plus false positive. And it is coming out to be 88.9%, 80 divided by 90. A high precision means the model rarely flags something as positive incorrectly. Recall, also called as sensitivity or true positive rate, answers out of all actual positive cases, how many did the model correctly identify. Formula for this is true positive divided by true positive plus false negative. Recall is coming out to be 80% in this case, 80 divided by 100. This tells us the model catches 80% of the real positives. So F1 course combines precision and recalls using the harmonic mean. Formula for it, twice the precision into recall divided by precision plus recall. And it is coming out, precision is of our numerical is 0.89 and recall is 0.80. And so our F1 score will coming out to be 0.84, which is 84%. F1 is usually useful, especially when the dataset is imbalanced. So after summarizing this question, accuracy, find the overall correctness, precision positive, predicts correctly, recall ability to find the actual positive, F1-Score balance of precision and recall. So that is with the 5th question. We'll cover the next question in the next video. Thanks for watching. Hope you find it informative.